I've just refitted the foot brake, which operates like that. So this rod passes through the swarf tray, comes down here where it operates a micro switch, and is pivoted here, adjustable, and then this operates like that. It's pivoted here, and this bolt operating in this hole just limits the travel, and this spring and another one on the other side holds it up. The one on the other side is there with another spring, and the micro switch is normally pressed but is released when you put your foot on the foot brake, thereby breaking the circuit and stopping the motor electrically and mechanically, like that. And it looks like that at the front. Well, I've been slowly tightening this lock ring using the C-spanner, and it's you have to apply quite a lot of force onto that, so I've had to use this, which I happen to have, which is the chuck key, well, the cam lock key. By engaging this in one of these things and resting it against the ways here, it enables me to lock the spindle and therefore apply a reasonable amount of force like that to tighten it. You're supposed to put the dial test indicator on some flat thing fitted in the spindle, but I haven't got something, so I'm putting it on the edge there. This surface here is so scratched that you can't get an accurate indication of run out by moving it around like this. But what I'm concerned with is not run out but end float, so if I push it backwards and forwards, I think that the end float is not more than 4 microns, and it says it's not more than 5, it says. It's got to be, because this is 2 microns per division, this DTI. I think that's fine. Actually, measuring it with the same DTI that I used before, I think the run out is near as damn it exactly the same as it was before. So taking the spindle out and putting it back again hasn't adversely affected it. Right, I've put 2 little magnets on either side where the headstock bearings are supposed to be oiled. They're probably not necessary, but I had them, so I might as well put them in there. So I fitted a new electric cable ready for 3-phase. So I put the gears back on here, rewired this, replaced the emergency stop, which I broke when I was trying to get it take it apart last time. So that's all ready to go. This bit of the case is one of the few bits of the lathe I haven't actually repainted. Could do, but couldn't be bothered. Well, the apron was standing for several months with oil in it, and it didn't seem to be leaking. However, when I put it back on the saddle, there was a slow drip of oil leaking from the bottom there. This thing's upside down at the moment. And so I used an Allen key to tighten all those screws securing the bottom plate to the apron casting. I'd already done them up what I thought was the appropriate tightness, so tightening them more actually made the thing worse. So it's now been leaking quite significantly. So I had to take it off, and when that's drained, I'm going to take that bottom off and see why it's leaking. So it was leaking from these two and not from these two. And if I turn it over, these two were leaking, these two were not. And I can't see any difference. This is a good joint washer. It's well fixed to the base here. All these holes are blind, so it's not actually leaking along the screw holes, although it was leaking from the screw holes. So, I don't know how I solve this. And of course I don't know whether it's leaking from here up the screw hole or underneath this, but it seems to be reasonably fixed to this base here. So I'm thinking that I don't really know the exact mechanism of this leak, but we've got to have more sealing on here, perhaps on both sides of the joint washer. So it was leaking from these two, and yet they are firm. The joint washer is firmly, well, on the inside it's firmly stuck down. This one might have been not so well stuck down, but mainly it's quite well stuck down. But I think what I'm going to do is take it off. I've got these two things, both of which are proof against oil and diesel and petrol and this, that and the other. Coat the joint washer thoroughly on both sides with this. Well, I'm thinking I have to make yet another new joint washer before I do that. Clean off all this Hylamar. Bit of a nuisance, this. Right, well, I've covered both sides of the new paper joint washer with Heldite liberally. And I've made that joint washer exceptionally carefully and made sure that the holes are the right size for the screws, or no bigger than necessary, and in exactly the right place. Right, well, I've done that up to a modest tightness with the Heldite still wet. Maybe I should have left it till it was tacky first. I always read the instructions after I've done something rather than beforehand, because I find that maximises the number of mistakes that I can make. Anyway, we'll let that go off for 24 hours before putting the oil back in. Well, I'm really struggling with this apron. So the biggest drop comes from here, but that could just be because that's the lowest, happens to be the lowest point. I'm going to do up these screws along the front here, or just slightly. Right, so I've tightened up 1, 2, 3, 4, 5, those 5 screws along here, left the other ones at the other side untouched and dried and swiped off all the oil. So we'll see what happens in 2 days' time. Well, it's the next morning, and although there's nothing on the bottom of this, there is oil collecting along this line, along the line of the joint washer. There's either an insufficient seal on one side or the other of the joint washer, or the oil is coming directly through the joint washer. Whatever it is, I think I'm going to have to take the apron off for a third time, remove this bottom and contemplate what to do about it. This thing is a nuisance.